Alright, so here is a video on this review sheet. So number 1, find a vector has that initial point and that terminal point and find its component form and magnitude. So for number 1 I would do 8 minus 3, so I'd get 5, and then negative 2 minus 7, so I get negative 9. So therefore I would have that vector, I guess it's called v. So the magnitude of v would be the square root of 25 plus 81. So that would be the square root of 106. And you don't have to reduce it, but you could probably, let me see, divide by 2, 53. Nope, doesn't reduce. All right, so for number 2. Number 2, find the direction angle of this vector. So the vector is negative 7i minus 2j. Well, so that is in the third quadrant. So when I go ahead and use my formula, tangent is negative 2 over negative 7. So when I do the inverse tangent, and on my calculator, so I put in 2/7 because 2 negatives makes a positive, it tells me 15.9 degrees. Well, that means that it's 15.9 degrees right here, so I have to add 180 to that. So 195.9 would be my answer. For number 3, find, given two vectors, find 1/2 u plus 4w. So that means 1/2 u is the vector 3, negative 2, plus 4 times w, well, w is the vector 9 and 5. So let's see, this would be 1.5 and negative 1, plus, what, 36 and 20. So together that would be 37.5 and 19 would be my new answer. You can put i's and j's, whichever. All right, number 4 says find the exact component form. We have a magnitude of 8 and a direction of 120. So this is where you put the 8 in front. We have the cosine of 120 and then the sine of 120. Hi. It's fine. I don't care.
I'm so sorry.
No, it doesn't matter.
I
I don't care. That's okay. They can hear me talk. Oh, it's just another review video.
No,
Fine. Don't worry about it.
I'm going to ask you.
Oh yeah, go ahead. Just.
Well, I'm going to ask you from now on if it's real or video.
Oh no, it doesn't matter at all. Bye. So the cosine of 120. So 120 is 60-degree angles. So 60 degrees right here. So the cosine, let's see, is negative 1/2 and radical 3 over 2 for the sine from the unit circle. Yeah. All right, so this part's negative 1/2 and this is radical 3 over 2. So my 8 times that would be negative 4. And then 8 times here would be 4 radical 3. So this would be the exact values of that. So it's just, you know, so you don't put it in your calculator. So basically you're getting it from the unit circle. Okay. All right. So in number 5, tells you you have basically those 3 forces there. So what you're doing is you're just making up 3 vectors for these things and you are adding them together. So just like you did in number 4, make up that vector, we're going to do the same thing. So we have the first vector, 500 pounds and 30 degrees. So 500 cosine 30 and sine 30. And then another vector, 200 cosine negative 45 and sine negative 45. All right, and so what we're interested in is the resultant. So we're adding these together. So I'm just going to go ahead and do it on my calculator. I don't really need the individual things. I just need the addition of the 2. All right, so I got 500 cosine 30 plus 200 cosine 45. Okay, so there's the first one. I'm going to re-enter that and change all the cosines to sines. And there's the second part. So I'm just going to say 574 and 391. Doesn't say it around, so 574, 391. That's the resultant. And so I just need to do the magnitude and the direction. Well, the direction, this is in the first quadrant, so direction will be second tangent of the b over a, so 391 over 574. Okay, so the direction angle is that angle because it's in the first quadrant. And then the magnitude, I got 574 squared plus 391 squared. So there's a magnitude. All right, so that many pounds. All right, number 6, a unit vector. So number 6 has a 3-dimensional vector. So the magnitude of that vector is square root of 16 plus 4 plus 25. So it's the square root of 45. So it wants a unit vector. So the unit vector is going to be 4 over radical 45, and then 2 over radical 45, and then negative 5 over radical 45. So that maintains its direction, but it makes its magnitude equal to 1. And of course, you can reduce the radical 45 and rewrite it differently, but it's fine. All right, number 8. Explain how you can tell if two vectors are parallel to one another. So in your test, you're going to be very picky about this. Parallel vectors are scalar multiples. That's how you tell that they are parallel. Scalar means you're multiplying by a number, and multiples means you multiplied by the number. A scalar is just like a number, and multiples means you multiplied by that number. All right, so scalar multiples. So give a vector parallel to 2, negative 5, 3. I don't know, let's multiply it by negative 3. So I'd get negative 6, 15, and negative 9. So these two things would be parallel to each other. Okay. Number 9. Do the following. All right, so number 9, the first thing says to do u cross v. So the cross product. So I put ijk. U is 3, 2, negative 5. That has to come first. V is 2, 1, 3. So to do my cross product, I cross off my I column, and I do the crisscross determinant of these 4 numbers. So 6 minus negative 5 would be 11. So that would be 11. Then I cross off J. I do the crisscross determinant of these. 9 minus negative 10. So 9 plus 10 is 19. But remember the middle, I change it the opposite. And then the last one would be 3 minus 4, so negative 1. There's my cross product. Remember that cross product is going to be perpendicular to each of these original vectors right here. So their dot product will be 0. These two. All right, so part B asks you to do u dot w. Well, let's see. U is this guy right here, 3, 2, negative 5. I am dotting that with w given, 5, negative 3, 4. So let's see, we get 15 plus negative 6 plus negative 20. So negative 11. In part C, find the angle between vectors u and w. All right, well this was a dot product of u and w, so remember the angle is this, the dot product, over their magnitudes multiplied together. All right, so cosine of my angle, I got negative 11 for the dot product already. There was u and w, so the magnitude of u is 9, 4, and 25. So 9 and 4, 13 and 25 is 38. And the other magnitude, 25, 9, and 16. So 50. All right, I'm tired, so I don't want to add those things in my head. All right, so I just need second cosine of that angle. Let's see, of that number, negative 11 over the square root. I'm just going to put these both under the square root, 38 times 50. Okay, there's that angle, 104.6. Now remember, if somebody asks you for when you have two things crossing, like the bigger one, 104.6, if you want the small one, you would just subtract from 180. So if you needed the acute angle instead of the obtuse angle, you could find that. All right, so number 10, this little practice with 3D points. Number 10 says find the magnitude of this vector with initial point 3, 0, 2, and 4, 3, negative 5. So let's first of all find the vector. So I could do 4 minus 3. 3 minus 0, and negative 5 minus 2. It says find the magnitude of this vector, so that would be 1 squared, 3 squared, and 7 squared. So the square root of 59 is the magnitude. Number 11, area of a triangle. So area of the triangle, this is a little bit of an annoying one. I have to do the formula 1/2 the magnitude of the cross product. So this is going to take a little bit of space. So let's draw this out here. I don't care what the triangle looks like, I just need to kind of orient myself. I have to find a vector from like A to B. So that would be B minus A, so negative 3 minus 2 would be negative 5, 1 minus 1 would be 0, and 3 minus negative 4 would be 7. So that's the vector there. And I just need one more vector. I could do AC or BC, it doesn't matter, I'm going to do AC. So from A to C, so C minus A would be negative 2 minus 2, negative 1 minus 1, and 0 minus negative 4, 4. So remember what I have to do is do the cross product of these two vectors, because they are two sides of the triangle, and then half the magnitude of that cross product. So I, J, and K. Now in this case it doesn't really matter which one I put first, because I'm not interested in that third vector, I'm just interested in the magnitude of it. Negative 5, 0, 7, and that won't change no matter what I do here. Okay, so I need my vector. So my cross product, I'll cross this off. Nothing minus negative 14 is positive 14. Cross off the middle. I get negative 20 minus a negative 28. So negative 20 plus 28 would be 8, but I'm changing the sign. And the last one, negative 10 minus nothing. All right, I need the magnitude of this. So 1/2 the magnitude of this thing. 14 squared is 196, right? Yeah. 196 plus 64 plus 100. So 196 plus 164 is 360. So 1/2 radical 360. And you know 360 is 36 times 10, so that would be 6 radical 10. So if I wanted to be all fancy, I could say that I have